with the beautiful girl that I met made in Japan.
Hi everyone, today I will briefly explaining to you guys about what is differentiation. Have you guys ever wondered what is the meaning of a differentiation and how we can apply the technique of differentiations in our daily life routine? So first of all, differentiation is a mathematical process to determine how a function change as its input change. In a simple terms, basically differentiation can be classified as a fundamental process in calculus used to find the derivative or finding the rate of change of a function with respect to variables. It helps us understand more how a function can change at a specific point. Basically, differentiations measure how fast or slow something change over distance or time. For example, differentiation can be used to calculate the speed of the moving object, the growth of a population. On the other hand, in graph, differentiation is used to find the gradient or slope of a curve at a particular point. Let's move to the techniques of differentiations. We'll be explaining the three of them, which are the most and the core technique of differentiation. Basically, first of all is the product rule. Product rule is used when differentiating the product of two functions. The formula of the product rule is uv equals to uv prime plus vu prime. Next, the second one is the quotient rule. The quotient rule is used to find the derivative of a function that is a fraction where both the denominator and the numerator contain x. The formula of quotient rule is dy over dx is equals to vu prime minus uv prime divided by v square. What is the terms mean of the formula? So u is the top function, which is the numerator. uv prime is the derivative of the top function. V is equals to bottom function, which is denominator. And lastly, v prime is the derivative of the bottom function. So the last formula is the chain rule. Basically, chain rule is a fundamental formula that is used to find the derivative of a composite function, which means that a function nested inside another function. Mainly used in a function that has a bracket, such as y equals to 3x squared plus 5 power of 4. The formula of the chain rule is d over dx is equals to f gx equals to f gx multiplied by gx. So what is the applications of the differentiations? So differentiation is mostly useful in things such as physics and also business and economies. From here, there are proven that differentiation is basically important in our daily life. So that's all from me.
Hi guys, so for my part, I'll be doing question 2, in which it asks. This will be the two formulas that I will be using for these two questions. Okay, so let's start with question A. Y equals to ln x by the power of 2 times x minus 3. What do you have to do first? You have to separate all these four equations. So this one. So why do you have to separate? This is to inform us which is which to be easier to differentiate. Okay, so now as we all know, let's look at the ln first. So how to make it easier? Put the 2 in front, so 2 ln x. But don't get confused, just the simplified part. Okay. So now let's identify which is u, v prime, v and u prime. So as we all know, this is u. So how do you do u prime? Ln x equals to 1 over x. So take 2 times with 1 over x. So 2 over x. So how about v? V is 1 x minus 3. So what is the differentiation in time? So as we all know, the differentiation in time is sec by the power of 2 x minus 3. That's it. Now let's insert the findings that we got and put it in the formula. So u, which is u 2 ln x, okay? V prime is this one, sec plus, which is v times, which is u prime, so 2 over x. Okay, so how do you solve this? Some questions like this don't require until you get a number. You can just leave it like that because we eventually put it in the formula and we got the needed equation. Okay, so now we know, let's simplify in which if there's anything that can be simplified. So dy dx 2 ln x sec plus, okay, this we can just simplify by time. Oops. Okay, that's it. That's the only answer we need because we don't have to search for x or anything. We can just put it like that. So for the next question I'll be doing is question B. What makes it different from the first question? So it makes it different because this is fraction. So we'll be using the quotient rule instead of the product rule. Because the product rule is used for standard equation, while the quotient rule is often used, not often, it's always used easy to put it in front. 2x, so 1 equals to 0, so that's it. So for the v prime, cos x, how do you differentiate? So, as we all know, the differentiation of cos is negative sin. So it's very easy, just insert negative sin x. That's it. Now that we all got the u, v, u prime, and v prime, so let's just put it in the formula. So the formula is v u prime, dy dx, cos x, u prime is 2x, minus u is x, and v prime is negative sin x. And don't forget this, so over what's v? Cos x. You know this is 2x cos x minus, can we simplify this? We just put it like this, in this shape, because we can't simplify it anymore. So, okay, last but not least, is for the cos. So the 2, put it here. So that's it. That's the final answer.
Now, let's move on to question number 3. First, we must differentiate both sides with respect to x using chain rule and product rule. This term become 1 over y dy over dx. This term requires multiple layers of chain rule. So, we must think of this. Okay, now we must bring exponent 2 to the front. We must know that derivative of cos is sine, so it will be negative sine. We must differentiate x power of 2 plus e power of y. So it will become this. For this part, we must add dy over dx because of y. Multiply all the equation, so it will become like this. We know that the math identity is 2 sin theta cos theta is equal to sin 2 theta. We can use that to rewrite this as this. So our new term looks like this. X and y are multiplied together, we must use product rule. Put the equation back together. Now, we must replace the original terms with differentiate version. Next, group all the dy over dx on the left. Next, factor out our common dy over dx on the left side for dy over dx to get the final answer.
Hi, so I will be doing the last question. So I will write this equation back and then let fx equals to, as you can see, this number, I will change it to s. So it will become s squared minus 1 over 3 root s. And as you can see, we don't want this to be fraction, so I will change it to s 1 over 3. And then I will bring this up, so it will become like this. S squared minus x negative 1 over 3. So we will move on to f prime x. So this equation that we just got now. And then these two, I will bring it to the in front, so it will become 2x minus negative 1 over 3 x negative 4 over 3. This x, I will move it to down, so it will become like this. Since this negative, so it will become positive 1 over 3x 4 over 3. On to the next step, we have to write the value. So given value is 8.02 and s naught, which is change value, is 8 because it's easier. So the formula is delta s equals to h minus s naught. So 8.02 minus 8, and it will become 0.02. So fx naught plus f prime s naught times to delta s. So what we're going to do is substitute this with this equation back. But we use the given value, we use the change value, which is 8. 8 squared minus, which is this equation. And then you just settle all this, so it will become, minus 1 over 1 and times with 0.02. So the total is 63.82. So this is the 2 decimal places, which is the question asked for, and this is the way how to use linear approximation to estimate a value.
In conclusion, we have successfully demonstrated the core tenets of differentiation by applying the power, quotient, and chain rules to our problem. So by following these steps, we have shown how even complex functions can be broken down and solved. These tenets are vital tools in calculus and allowing us to understand rates of change in everything from physics to economics. Thank you for watching.